ค้าง
keeping our oceans safe from invasive species, and helping our crops flourish while minimizing pesticides. I am
เพสติไซด์
อะไรเนี่ยกระตุกเนี่ยฮะ
เอาเหรอเป็นที่ทางนู้นนะรีเฟรชนะฮะ
เสียงซาวเวลาเปิดมา
รีเสียงซาวของไอ้นี่ลงนิดนึงครับมันแตก
ทั้งแตกทั้งซ่าเลยซาวที่อาจารย์เปิดของ Nvidia มาแสดงว่าไอ้กระสันโซเชียลก็คงไม่ต่างกันนะอันไหนที่มาซาวลกๆเยอะๆเนี่ยเป็นกับพวกซาวลกๆเยอะๆนะมันแก้ปัญหาไงเป็นที่สกายหรอ
ไม่เกี่ยวเอาลองเข้าไลฟ์ใหม่สิ
and a learner discovering new strategies from complex games.
ยังเป็นอยู่นะ
Computing.
ยังไม่เห็นเลย
ขึ้นใน YouTube แล้วครับแต่ว่าในนี่ต่อไป
There are two dynamics that are
อันนี้เขา
happening
พูด
in
ถึง
our
ฟิสิก
industry
ส์แล้ว
at
ก็
the same time.
computing นะครับ
I'm going to talk about both of them. This is the first one. For the last 30 years, we have benefited from one of the most powerful technological revolutions that anybody's ever seen. The combination of two effects created what is known as powerful technological revolution. One, architectural innovation that makes microprocessors better and better, more and more performant through architectural techniques. The goal is to find instruction level parallelism. And it's magic. Just think about what they're trying to do. Basically, a program is a sequential list of instructions, and it's performed one at a time. But somehow computer scientists have figured out
สวัสดียามดึกนะครับวันนี้มางาน Nvidia GTC กัน
Well, one of the ways that you do it is pipelining. To start the next
แต่ละคนก็
to start the next
ตา
step
จะเป็นมีแพนด้ากันหมดละตอนนี้เขากำลังพูดเลยครับแอดข้าว
พูดถึงการพัฒนาตัวโปรเซสเซอร์ครับมีลักษณะพัฒนาขึ้นเรื่อยๆนะฮะ
All kinds of amazing technology was created. Cache has got lots bigger, and then of course software techniques on top of it, optimizing compilers, made it possible for us to advance microprocessor architecture performance.
พูดถึงซอฟต์แวร์นะฮะที่ช่วยให้ตัวของฮาร์ดแวร์นี่ทำงานได้ดีขึ้น
wouldn't have been possible to use if it wasn't because of a second law, the law of Dennard scaling. Dennard scaling basically says that we can put more and more transistors into a constant area and run them faster and faster, so long as we continue to reduce its voltage, so long as we continue to make the transistor smaller, reducing its capacitance. And by doing so, the combination of these two factors, more and more transistors, running them faster and faster at a lower and lower voltage, allowed us to continue to advance performance within some constant energy envelope. In the course of the last 30 years,
ถ้าจำกันได้กฎของมัวนะฮะก็คือโหนดเล็กลงเรื่อยๆแล้วก็ทรานซิสเตอร์เพิ่มขึ้นเรื่อยๆ
by nearly a million times. Nothing in society has improved by a million times, and everything in society has been made possible in the course of the last 30 years.
ถ้าจำกันได้กฎของ
Then in the last several years, it started to slow. Our abilities to harvest parallelism out of instructions, sequential instructions, started to diminish. And the number of transistors that we had to add in order to squeeze out that little tiny bit of extra performance was simply too costly. On the other hand, we were reducing voltage, shrinking transistors, and we're now up against the laws of semiconductor physics.
ลดโวลเทจลงใช้โหนดที่มีขนาดเล็กลงแล้วก็เพิ่มทรานซิสเตอร์เข้าไป
Dennard scaling started to fail on us. We now have found ourselves at the end of two roads. And it's been incredibly well documented. We started talking about it, in fact, for many of you who've been coming to GTC all these years, I think I spoke about it at the first GTC. I speak about it at every GTC. And it's the reason of our existence. recognizing that we need to find a path forward, life after Moore's law. John Hennessy recently talked about it. He called it the end of the road for general-purpose processors and the future of computing. Mark Horowitz, also a professor at Stanford, spent enormous amounts of time with his colleague, basically plotted out every single major event and processor product and node in the last 30 to 40 years. And the results are actually quite amazing. The blue line basically shows the Dennard scaling compounded with the lack of productive architectural innovations has led to the plateauing of processor performance.
พูดถึงกราฟที่พลอตอยู่นะกราฟสีฟ้า
50% per year compounded improvement is now improving at 10% per year. Yet, we can manufacture the transistors. The transistors are abundant. And in fact, if you look at it, look at that white line, that shows you how much transistors we have. And that was the ultimate observation of the beginning of our company. That observation was the reason why accelerated computing works. And it is the reason why we introduced the concept of GPU computing. GPU computing does several things.
อันนี้เข้าถึงเรื่อง GPU computing
The microprocessor is incredibly good at sequential instructions. It's incredibly good at single-threaded operation.
พูดถึงข้อดีของการใช้ GPU มาทำsequential instruction
And we respect the other law of computing, Amdahl's law, that if we were to accelerate the things that we could do, the part that we can't accelerate eventually becomes the problem. And so we have to make sure that we honor that law as we change the architecture of computing. We did several things. The first thing that we did was we realized there's some workload inside some very important applications, Frankly, these applications are the ones that the reasons why you are here. They're the algorithms of artists, of scientists, of engineers, of the explorers, the discoverers, the inventors.
เดี๋ยวผมจะสรุปตัวเดียวเลยนะครับเพราะว่าเขาพูดแบบเกริ่นค่อนข้างจะเป็นลักษณะเหมือนกับอธิบายถ้าพูดง่ายๆก็คือตรงนี้เป็นน้ำอยู่นะ
That if we could figure out a way to offload of the microprocessor that was good at sequential processing, we could provide incredible speed up. So the first thing is to create a specialized, domain-specific accelerator that is a companion to the CPU, accelerated computing. The second thing we did was create an architecture that had a platform that we were willing to dedicate ourselves to everything we did for the rest of our lives. We created an architecture we call CUDA. And it's named after an architecture that we created at the very beginning of our company 25 years ago.
ที่เขาเกริ่นมาสุดท้ายเขาก็จะเข้ามาถึงเรื่องของ Nvidia CUDA นะฮะ
That architecture was extended for computing.
ได้เปรียบการใช้ CPU ในการมาประมวลผล
That architecture was extended for computing starting 10 years ago. We call it CUDA. This architecture is our computing architecture. And a computing architecture that you dedicate your lives to, and you continue to promote, that you continue to sustain, you continue to improve, and it continues to add value, eventually, other people can benefit from it. It has to be special.
พูดถึงว่า CUDA เนี่ยทุกคนจะได้ใช้ประโยชน์จากมัน
That commodity computing or available otherwise generally available computing cannot do. It has to be special. It has to be something you dedicate yourself into. It has to be something that is available everywhere. It can't just be available on a PC. It has to be available on a laptop. It has to be available in the cloud. It has to be available in embedded devices. It has to be available everywhere. It has to be thought about from
พูด
top
ถึง
to
ว่า
bottom.
CUDA
In the
นี่
sense that
มี
you have to have
ทุก
tools.
ที่
You
เลย
have
ฮะ
to have
PC
middleware.
console
Because computer architecture,
embedded
computer
system
scientist needs all of that to be productive. What's really special about GPU accelerated computing was that it took enormous amounts of effort to port, to refactor for all of you the applications you've developed on top of microprocessors onto this new computing platform. It took time. And it took specialized skills. And so we dedicated ourselves to having a team of computational mathematicians that can think across the entire stack. So we work with you, work with the application makers, the algorithm developers, to find that match between the work that you want to do and the architecture we created. We worked at the architecture level, at the system level,
สถาปัตยกรรมของ
software level,
Nvidia
at the
เนี่ย
algorithm level,
จริงๆมัน
and then we worked at the
ค่อนข้าง
application
ที่
level.
จะใช้งานยากนิดนึงเขาก็เลยมีทีมงานมาช่วยนะครับเวลาคุณจะทำแอปพลิเคชันอะไรต่างๆเนี่ย
You're going
เพื่
to
อให้
have
ใช้
to
งาน
be
ได้
pretty
ถูก
clever.
ต้องตรง
And
กับ
you have
งาน
to
มากขึ้น
think
นะครับ
across every single possible layer of computing to find efficiencies, to get rid of waste, to do special and smart things. This way of doing computing, top to bottom, then bottom to top, top to bottom, then bottom to top, dedicated to one single architecture over the course of the last 10 years, the results have been phenomenal. If you look at the green line, that's basically the line that NVIDIA is tracking. Some people have described our progress as Moore's Law squared. And the reason for that is because, first of all, you get a big speed up. You get a big speed up over the natural microprocessor performance. Secondarily, it appears to be moving faster than the rate of increase of transistors. And I think there's some logic to that. And the reason for that is exactly as
เขาเปรียบเทียบระหว่างโปรเซสเซอร์ธรรมดาแล้วก็ตัว GPU โปรเซสเซอร์เนี่ย
for many of you who have been
มันทำงานได้ดีกว่าโดยไม่ต้องเพิ่มทรานซิสเตอร์มากนักนะครับ
I want to tell you how much I appreciate all of your support. We come here because the work that we do is impossible otherwise. The work that we do is impossible otherwise. The work that we do in creating virtual reality is impossible otherwise. The work that we do in computer graphics, the work that you do in fluid dynamics is impossible otherwise. In molecular dynamics, it is impossible otherwise. There are several regions, several domains that we have found accelerated computing to be incredibly effective. Of course, graphics, physics, quantum mechanics, and a new field called deep learning.
เปรียบเทียบให้เห็นว่าการใช้ GPU มา computing เนี่ยมันพัฒนาขึ้นมาเรื่อยๆนะครับ
We now have increased by a
จาก
factor of
7,000 ตอนนี้ขึ้นเป็น 1 ล้าน
the
แล้ว
number of attendees. Now, the only reason why it hasn't grown faster is because of the fact that computing is all over the world. Since last year, starting last year, we've taken GTC on the road. Last year alone, over 20,000 people came to GTCs around the world. And this year, we're going to take this show on the road again so that we can make this computing platform available for developers, scientists, and researchers for your groundbreaking work all over the world. The number of GPU developers has increased by a factor of 10 in 5 years. It's actually amazing. 500,000 developers. It's taught all over the world. Textbooks are written all over the world. When you look in LinkedIn, you see CUDA all over the place. It's just fantastic. The number of people who now consider GPU or programming GPUs or programming CUDA, one of their specialties is really fantastic to see. And then over 1 million CUDA downloads. The CUDA driver, the CUDA software SDK.
พูดถึงการ support การใช้งาน CUDA นะครับมีทั้ง SDK แล้วก็ driver อะไรต่างๆนานา
Every one of the top 15 technology companies in the world are here. 100% of the world's top 15 technology companies are here. 10 out of the world's top 10 car companies are here. Pfizer, Merck, and Roche, GSK, Amgen, Lilly are here. Researchers from the world's top 100 national laboratories are here. There are 80 AI startups here, 25 VR startups, all kinds of robotic startups and ideas. GTC is where, if you will, the future is invented. GTC is where we create what other people would think of as science fiction. And speaking of science fiction, my first demonstration for you today is the holodeck. As you know, we play at the intersection of virtual reality and artificial intelligence. We play at the intersection. And nothing exemplifies that intersection like holodeck does.
ฝากแอดเน็ตดูแล
is not only
หน้าต่างแชท
a
ด้วย
place
นะครับ
to go, but it's a place we can share. And so it has to obey the laws of physics, otherwise it wouldn't feel like a place. It has to be photorealistic, and it has to be someplace that we can share together. And so I thought, gosh, what can we share together? What can we share together? And so I thought it would be great to invite a friend to join us from Sweden. And he's actually a pretty special guy. His name is... There are many more jokes to come. Watch. Some of it is just going to be right in here. It's incredible. And so I invited Koenigsegg to come and show us something that most people have never seen. And to enjoy...
ช่วงนี้จะเป็นลักษณะที่เขายังเกริ่นเหมือนกับเล่าประวัติอะไรของคูด้าอะไรต่างๆนานานะ
Hey guys.
โอเคเดี๋ยวคุณอานนท์เดี๋ยวรอแปลเรื่อยๆนะครับเราจะมีอธิบายเรื่อยๆนะครับสำหรับงานนี้
Christian
คุณสุภชัยถามว่าอย่างนี้แสดงว่า
Just stepped out. He'll be right
เขา
back.
พยายามเอา GPU ไปแทน CPU เต็มตัวเลยตามจริงเรื่องนี้เขาใช้ในวงการแพทย์นานแล้วครับและงานวิจัยก็ใช้นานนะครับแต่ว่าถ้าถามว่าจะใช้เต็มตัวเลยไหมจะเป็น OS เฉพาะทางนะครับ
อันนี้เป็น AI นะครับที่ตอบสนองกับการพูดของคุณหวงนะฮะ
จำเมื่อตอนเย็นได้ไหมที่ผมเกริ่นว่าเรื่องของ neural network ก็เสียงมันตีกันนั่นแหละครับระบบที่ใช้ GPU ในการคำนวณปัญญาประดิษฐ์นะครับตอนนี้ Nvidia เขากำลังพัฒนาเรื่องนี้อยู่
ใช่ฮะ
ทำไมผมต้องรู้ก่อน พอดีผมไปสืบมาก่อนแล้ว
ไปศึกษามา
หน้าตาไม่ให้เลยนะครับเนี่ย
ใครครับ
เหมือนของแอดเน็ตหลุดหรือเปล่า
ภาพมันหายไป
ภาพมันหาย
ไป
ภาพไปมาครับคุณสุสราวุธถามว่างานอะไรอันนี้เป็น Nvidia GTC ครับดึกแน่นอนครับเพราะว่าต้องตามเวลาบ้านเขาเช้าครับ
3 โมงเช้าครับ
คุณอานนท์บอกว่าไม่ใช่เกี่ยวกับเรื่องคำพูดครับเขาบอกว่าที่เนี่ยตะลุงเนี่ยเดินไปเดินมาเนี่ยแล้วเวียนหัว
คือ
เดี๋ยวผมอธิบายช่วงท้ายดีกว่านะ
GPU ของ Nvidia ตามที่ผมเรียกแกตาลุงห่วงนะเป็นความแกเกริ่นถึงประสิทธิภาพของ GPU Nvidia ที่มีสมรรถนะค่อนข้างสูงแต่ว่าที่ผ่านมาเนี่ยคือเขาเหมือนกับใช้ประสิทธิภาพของมันยังไม่เต็มที่มันเป็นในเรื่องของตัวซอฟต์แวร์เรื่องของระบบปฏิบัติการนะตอนนี้ถ้าจำไม่ผิดเนี่ยวิศวกรของ Nvidia เนี่ยเขากำลังเฟ้นหาผู้พัฒนาซอฟต์แวร์นะครับที่เมื่อกี้เกริ่นไปว่า neural network เนี่ยคือมาคิดเรื่องของตัวซอฟต์แวร์ประมวลผลที่จะทำให้ดึงประสิทธิภาพของ GPU ของ Nvidia ให้มีประสิทธิภาพที่สูงกว่าที่เป็นอยู่ทุกวันนี้นะฮะก็หลักๆคร่าวๆนะน่าจะประมาณนี้
Now, Christian, you know that the first time you sold me a Koenigsegg,
เสียงมันแตก
ขออนุญาตโฟกัสนะครับหลุดไปนิดนึง
อันนี้นิดนึงนะอย่าเพิ่งแยกกันพูดนะเพราะเสียงที่เข้ามาในหัวมันแตกเวลาซ้อนกับเสียงของวิดีโอครับโอเค
her grandson in the car. But I had the perfect excuse. I was going to say that if I got stopped, I'm taking the car to the showroom. And apparently that was going to work because you told me that would work. And that it was okay to drive an illegal car. All right, so let's take a look at this. Everything here is carbon fiber. Let's go inside it. Let's go inside it. Let's take a look. Amanda, let's take a look.
มันพูดว่าอะไรอ่ะมันเป็นเสียงหุ่นยนต์
อันนี้คงตอบไม่ได้ครับเพราะเสียงเราตีกัน
So if she were to grab the steering wheel, her hands don't go through it. Wow. look at that. Look at that.
ไม่เป็นไร
Oh, look at that.
มันเป็นเรื่องของปัญญาประดิษฐ์คือถ้าจำได้ Nvidia เขาเคย
All right, come on out, come on out.
ให้
Let's
ใช้
you guys
GPU
have an
เนี่ย
X-ray
ในเรื่องของ
picture or something
การ
like that so that we
ควบ
can
คุม
see through the car?
รถอัตโน
I
มัติ
just want to make
ถูกไหม
sure
ฮะ
that the entire car design is there.
อันนี้เขาจำลอง
Every
ตัว
single
หุ่น
body
ยนต์
part is in here.
จำลองโดยเสมือนว่าตัว
Nvidia car. This is
เป็น
actually
ตัวรถยนต์ที่
computer
ถูกบังคับโดยพวกเนี้ย
design car. This is
คือ
this
ที่เขาอธิบาย
database
ตะกี้อ่ะ
this
มันเป็นลักษณะ
database
ของ
is
AI
directly
ทั้งหมด
from
เลยนะครับ
Christian.
ใช่
And now that we
คือหุ่น
have
ยนต์ไปจับ
database,
เนี่ย
we can
ปกติ
predict
ถ้าเราเล่น
ourselves.
เกมเนี่ยมันทะลุนะฮะมันจับพวงมาลัยอ่ะมันทะลุเข้าไปเลยเพราะมันเป็นแค่กราฟิก อันนี้นี่คือมันจะรู้ว่าแบบตรงนี้เป็นมือนะตรงนี้เป็นพวงมาลัยรถนะจับปุ๊บแบบ
But what if
เห
I
มือน
want
คน
to
จับ
see
จ
like
ริงๆเล
all
ย
the parts?
Sure.
I just want to do an inventory of the parts.
ภาพหลุด
คือมันไม่ได้เป็นหุ่นยนต์นะฮะต้องเข้าใจกันก่อนมันเป็นเหมือนซิมูเลตจำลองว่าเนี่ยเหมือนกับคนกำลังบังคับ
Thank you very much.
จริง
All right, enough fun. Ladies and gentlemen, Christian Koenigsegg, the holodeck.
อันนี้
The holodeck. It is just so amazing to be in these environments together with all your colleagues.
อันนี้ก็คือโชว์เดโมเกี่ยวกับ AI ปัญญาประดิษฐ์นะฮะ
Because you could touch things, you could
ที่ใช้
actually lift things up.
ตัว
And because
Nvidia
you're
GPU มา
in
ประมวล
that
ผล
environment and you're superhuman, it reacts to physics.
ชื่อ
You can lift up
Project
amazing
Holodeck
things.
นะครับ
And so the holodeck is such a great place. The first part of the first dynamic is the emergence, the rise of GPU computing. The second thing that happened several years ago. And in fact, some would call this the second era, not of processing, but the second era of computing altogether. As you know, when you guys are doing a search on Google, somehow it magically knows what kind of information you're interested in. When you're watching movies on Netflix, somehow it magically knows what are other movies that you would enjoy. And when you're shopping on Amazon, it's amazing that every single page
อันนี้
is
พูด
personalized.
ถึงการเอาปัญญาประดิษฐ์มาใช้นะครับ อย่างเช่นเวลาดู Netflix ดูอะไรอย่างเงี้ย มันเก็บข้อมูลอะไรไว้ปุ๊บ มันจะเดาได้เลยว่า เราชอบดูหนังอะไร หรือว่าไปช้อปปิ้ง มันก็จะจำพฤติกรรมเราว่า เราอาจจะชอบไปซื้อสินค้าอะไร มันก็จะเสนอสินค้ามาให้เราให้ถูกนะครับ ใช้ในการค้า
It's learning from all of your behavior and all your interactions with that service.
AI พวกนี้เนี่ยจะเรียนรู้จากพฤติกรรมของเรา สิ่งที่เรากระทำไปเรื่อยๆนะครับ
It is almost able to
ก็เหมือนกับเด็กอะฮะที่เรียนรู้ไปได้เรื่อยๆ แต่ว่าอันนี้เป็นเรียนรู้ได้ไม่มีที่สิ้นสุด
is one of the most important computer revolutions ever. Whereas computer scientists used to specify every single instruction a line at a time. Now,
สำหรับนักวิทยาศาสตร์นะครับที่เขาพูดตะกี้ก็ต้องการตัวประมวลผลเนี่ยที่มีประสิทธิภาพสูงที่เพื่อจะทำงานเฉพาะทางได้ดียิ่งขึ้นนะฮะเนื้อหาจะเป็นประมาณนี้แอดเนี่ยลองรีเฟรชดูครับผมว่ามันน่าจะหลุดนะ
สัญญาณมาไม่หายฮะ
นะครับเดี๋ยวผมเช็คของผมก่อนนะยังอยู่นะฮะ
มาแล้ว
there are 5 tribes in machine learning. The symbolists,
ของผมไม่หลุดนะฮะ
ประเทศไทยออกนอกก็ต้องทำใจแล้วครับ
the Bayesians,
จริง
probabilistic,
ๆผมอยากจะตีไปให้แอดเนี่ยแทนมากกว่านะของผมไม่หลุดเลย
the analogizers, the evolutionists, the ones that believe in genetic programming. These 4 approaches are also making enormous contributions in computer science. But one particular tribe called the connectionists have recently bursted into the public consciousness. This particular approach, which is now called deep learning, is the culmination of research
เขา
breakthroughs
พูดถึง deep
from
learning
so
นะ
many
ครับ
different labs.
ครับ
From Schmidt-Huber's Swiss AI lab,
น่าจะฟังทันกันนะ
GPUs for convolution neural nets and the early uses of LSTM.
แอดได้ฝากดูแลคำถามเลยนะครับผมตอบไม่ทัน
Neural nets, to Jan LeCun's work with CNNs, to the groundbreaking work invention of back propagation by Jeff Hinton at the University of Toronto, the work that Fei has done on ImageNet and computer vision at Stanford, and of course, quite famous work by Andrew Ng on deep learning at Stanford as well. All of their works have come together into, if you will, kind of called the Big Bang of deep learning, the Big Bang of modern AI. And Feifei gave a talk recently
พูดถึง
where
AI
she
ใหม่ๆเนี่ย
was talking
แทบ
about
จะ
the
ค
search
ล้าย
for
ๆกับ
intelligence.
ทฤษฎี Big Bang เลย
And
ที่ว่า
she
มัน
said
ระ
that
เบิดออก
การ
the
ระเบิ
Big
ด
Bang of AI, what made it possible were three fundamental
คุณสุ
agreements.
ภชัยบอกว่าเสียงวิดีโอเบาไปหน่อยครับ
Breakthrough of deep learning
ลอง
was
เร่ง
made
ลำโพง
possible
ดู
by
ครับ
three
ผมว่า
things.
ผมดังแล้วนะ
Of course, the culmination of all of those great ideas that came
โทษที
together
ครับ
into the deep
ผม
learning
เร่งเสียงให้ละ
algorithm and the deep learning approach. The second is the availability of an enormous amount of data. And third is the discovery of using GPUs to accelerate deep learning, the training of deep learning, the
พูดถึง
development
เอา
of
GPU มาช่วยทำให้การประมวลผลในการทำ Deep Learning นั้น
Well,
เร็วขึ้นนะครับ
that combination set off in 2012 one of the most amazing
หลุดอีกแล้ว
Nvidia น่าจะไปสตรีมผ่าน
magically look at an image, determine what's the important features, learn the features hierarchically, from pixels to curves to objects, for example, my face, my ear, my nose, my eyes, to eventually turn it into a face, and my face. That it learned it hierarchically and was able to represent knowledge, represent information in this way by extracting it out of raw data all by itself. It is able to look at a picture of me and recognize that it is me. It is not only robust,
ให้
it is diverse. It could
พูดถึงให้
recognize me in the
AI เนี่ย
sun, in the dark, with a hat on,
ทำการจำแนก
half of my face occluded
แม้
in
กระทั่งหน้า
shadow,
ของตัวเขาเอง
maybe slightly turned away. It could recognize other people. It can generalize. The ability for these networks to not only be robust and diverse and generalize allows us to solve one of the great challenges of computer science up to this point, which is perception, sensing the real world, sensing raw data, whether it's visual or audio or otherwise. It could be vibration, it could be
ภาพหายครับ
เดี๋ยวก็มาครับ
เสียง
เดี๋ยวก็
หา
มา
ย
corporate storage. And all of a sudden, boom, by solving this problem, we just went on a massive race since 2012. One breakthrough after another was made possible because of it. Self-driving cars, the ability, Baidu using computer vision translating it to text, Google
พูดถึง
self-tagging
รถ
all the
รถที่ขับ
photographs that you
ได้เอง
upload.
ไม่
You
ต้อง
no
มีคน
longer
ขับ
have to tell it where this picture was taken. It figures it out. You could ask it for all of your pictures of beaches, and it'll find it for you. For the very first time, a deep learning network that was trained by data, not coded by engineers, not coded by computer scientists, was FDA approved for medical imaging, cardiac medical imaging. And it just keeps on going. Recurrent neural nets came along. The ability for neurons, these networks, to learn time sequence information so that it can understand sequences of text that turns into words, sequence of words that turns into paragraphs. All of a sudden, we have speech recognition that are superhuman. We have the ability to now look at a
เขา
video
พูดถึง
and
ระบบ
caption it
ปัญญาประดิษฐ์ที่มี
So
การ
this
เรียน
piece
รู้
of
นะครับ
software has
จำลองการ
learned
เรียนรู้
what is in the
เสมือน
video
เป็นคนจริง
and
ๆ
what
อ่ะ
it means. Captioning. Another architecture came along called reinforcement learning, where the network is given a value system and it tries and tries and tries and tries again exhaustively until it figures out how to improve itself towards the value system. Reinforcement learning, how we learned to just about do everything. As a result of that,
อ่ะ
เสียงหาย
เดี๋ยวมาครับเดี๋ยวมา
and it was a feat that nobody thought would be possible for another 20 years. Robots are learning how to translate computer vision sight to kinematics, hand-eye coordination. And it keeps on going. And now we have unsupervised learning. We have the ability to use autoencoders to enhance images, to fill in the missing spots.
ใช้
And then
ตัว
a breakthrough came
ตัว
along
ถอด
this
รหัส
last
ที่
year, or
แบบ
I guess
ถอดรหัส
Ian
อัตโนมัติ
Goodfellow's paper
เพื่อให้
was
เราทำงาน
2015,
ได้
but
ดี
this
ขึ้น
last
อย่างเช่น
couple of years,
การ
it's
ดี
really
เทค
taken
ภาพ
off.
หรืออะไรอย่างเงี้ย
Adversarial networks, training two networks at the same time. One network's job is to fool the second network. And the second network's job is to not be fooled. And so it's a little bit like one network learning how to be Picasso and generating images and paintings of Picasso, while the second network is learning how to discriminate whether it is truly Picasso or not. When you're done training this network, what you end up with is a network that is able to draw like Picasso, and you have another network that is able to recognize images and recognize paintings at a level of discrimination.
คุณสุภชัยส่งลิงก์มาให้นะฮะ
Generative
อยู่สตรีม
adversarial
ทีวี
networks.
นิ่งก
As
ว่า
a result, all of a sudden, all of these new ideas
อั
for
นนั้น
generation comes
อันนั้น
along.
เฉพาะของ
We
แอ
could
ดเน็ต
use
นะครับแอดเน็ต
create
ไป
things
เอาอั
like
นนั้นก็ได้
style
ครับ
transfers,
ของผมฟังสวิตช์
generating
ปกติ
voice,
ครับไม่มี
the
หลุด
ability to fill in empty spots or missing spots in photographs, natural language translation, to go from one language to another language, and to learn a pair of languages, and then transfer that learning to other pairs of languages.
น่าจะหลุดไปนะฮะของผมยังปกตินะครับ
ดูในแชทครับ
Just spotlight a few of the examples. The number of papers in deep learning is just absolutely explosive. There's no way to keep up. And it's literally everywhere
คือ
in
จะ
the
ส
world.
ลับให้ผมสตรีม
That
ขึ้นไป
big
แทน
bang, that second move, that
ผมไม่มีหลุด
second
นะ
dynamic of computing, the big bang of deep learning has really laid the foundation of what we now all know is the coming era of artificial intelligence, where computers are now able to automate programs. Automation of automation. Computers that program computers. Artificial intelligence. Let me give you an example of something that we've been working on. We also, in our company, we do a fair amount of deep learning research. Let me give you an example of what's actually happening here. Basically, this network in the middle, this is just an articulation of the network, it's called an autoencoder. We're asking this network, if we gave it a distorted image of that, a noisy image of that it has to learn how to generate that image, the beautiful image, from that noisy image. The way that it has to do that, it has to figure out how to recognize the important features and eventually generate it automatically. Now, one of the areas we've applied this to is ray tracing. Ray tracing, as you know, is computationally incredibly intensive, following photons around as we try to
ภาพ
regenerate
จะ
an
มาตอนแรก
image
เป็น
is very computationally
หยาบๆเป็น
intensive.
จุด
And
ๆ
so
แล้ว
one of the things
ใช้
that we
deep learning
decided to
นี่
do
ช่วย
is
ใน
what
การทำให้
happens
ภาพ
if
เนี่ย
we
คมชัดขึ้น
were to
นะครับ
teach a network to fill in the spots that we haven't rendered yet. Okay?
Yeah.
To generate some of it and to automatically infer or to use artificial intelligence to decide.
ภาพมันจะมีจุดที่หายไปด้วยนะฮะพอจุดที่หายไปเนี่ยเขาก็จะใช้ deep learning เนี่ยเข้ามาประมวลผล แล้วก็แต่งเติมจุดที่มันขาดหายไปให้มันสมบูรณ์นะครับก็เป็นภาพที่สมบูรณ์ขึ้นมานะฮะอันนี้ก็มีการเปรียบเทียบนะครับระหว่างตัว deep learning กับไม่ใช้ deep
What
learning
paint
นะ
looks
ฮะ
like, what glass looks like. It's learned those things, and it's selected the right picture, selected the right colors to fill it in with, all by itself. And as a result, you're able to take this noisy image and turn it into a beautiful image.
ถ้าเปรียบเทียบกันนะครับภาพทางขวาจะคมกว่านะที่ใช้ deep learning ช่วยนะครับทางซ้ายนี่อาจจะขาดรายละเอียดบ้างพอสมควร
The implication is actually quite amazing. We can now get distorted input from the sky, from the internet, and somehow we could have a network running here that regenerates what it's likely to be. Okay? Autoencoders, using deep learning for computer graphics. That's great. Thanks, guys. Now, this particular image, let's take a look at this. This is the full scene. Yeah, let me not forget this. This is now the full scene. Now, let's do the ultimate stunt. Let's go outside. And just like that, it fills it in. And it recognizes that it's a reflection of trees. And it renders a reflection of trees. Okay? Fantastic. Thank you.
ก็
using deep
โชว์
learning.
ระบบการใช้deep learning เข้ามาประมวลผลในการทำ ray tracing นะ
well
ค
on
รับ
its way. It started with the Big Bang in 2012, but since then it has grown. Has doubled in 2 years. It's only doubled in 2 years because there are limitations in physical space. The number of students who want to learn deep learning has 10x'd in 2 years on Udacity. The number one most popular course on Stanford, at Stanford, is CS 229, Introduction to Machine Learning. The most popular course, you would have thought home ec was, but the most popular course is not being a movie critic anymore. It's machine learning. And in fact, I understand that it's not just engineers, not computer scientists, but it's psychologists, it's biologists, it's oceanographers, it's basically everybody. Deep learning has democratized computing. Not everybody knows how to program, but everybody has data. Everybody has their own data.
พูดถึงการใช้ประโยชน์ของ deep learning นะครับไม่จำเป็นต้องรู้ว่าเขียนโปรแกรม deep learning ยังไงแต่รู้จากการนำข้อมูลที่มีมาใช้ใส่เข้าไปในการประมวลผลแบบ deep learning
We have democratized computing. And then lastly, the number of startups has just have been explosive. They're now 10 times as much investment in AI companies since 4 years ago. There's no question we're seeing explosive growth. Our strategy.
What is up, friends?
Of course, building great GPUs, but building great systems and system softwares and all the middleware that goes with it. The invention of cuDNN so that we containerized, we of course turned into a library, the really complicated numerics and mathematical processing of all of the layers, the convolution layers, the activation layers, the pooling layers, all of those complicated layers into a easy to use.
อ๋อ
Created now for the
อัน
deep
นี้จะเป็น
learning
ของ
SDK
Twitch นะครับ
that's available to framework designers and deep learning engineers all over the world. We work with every single one of the framework providers in the world. We have engineers that are working with each and every one of them so that we can integrate and optimize and make as wonderful as possible and as productive as possible these complicated frameworks, which are basically high-performance computing software stacks to run on
ส่งให้ในแชทแล้วนะฮะกดลิงก์ได้
every
เลย
single framework on the planet supports CUDA. Every single framework on the planet supports NVIDIA GPUs, and it doesn't matter which one you use. Some of them have their own special characteristics. Some of them are better for research. Some of them are better for production. Some of them are better for cloud. Some of them are better for enterprise. Some of them are better for the highest possible performance. Some of them are better for flexibility. There are so many different frameworks, and we support them all. We also work with the system companies to make sure that irrespective of how you would like to access a high-performance computer, whether you would like to build it yourself by going to the store and buying yourself a GeForce
พูด
Type
ว่า
Mouse,
เข้าไปช่วยบริษัทต่างๆนะฮะที่ต้องการจะใช้
buying a
GPU
fully
computing
integrated
เนี่ย
server from one of the world's
ให้ความช่วยเหลือ
largest
support
OEMs,
น่าจะเป็นลักษณะของ
IBM, Cisco, Lenovo,
เพื่อดึงดูดให้บริษัทต่าง
you
ๆ
would
มา
like
ใช้
to provision it in the cloud.
GPU ของ Nvidia ใน
One of
การ
the best ways
ทำงานเดียวกับ
to
Deep
enjoy
Learning
deep
นะครับ
learning is for someone else to build this incredibly complicated supercomputer on your behalf. And so we've worked with all of the cloud providers, and at this point, every single cloud company in the world has NVIDIA GPUs provisioned in the cloud. And so with this strategy, we have accelerated the capability of deep learning, made it compatible with literally every single framework on the planet, and made it available to you however you would like to access it. But we didn't stop there. There are several things that we're doing. Because we realize what an important computing revolution this is, and that we can't just make the computers for it, that we have to understand how deep learning works and how AI will impact society, Bill Daly and our NVIDIA research is doing basic research in deep learning. We also have applied research. I showed you one example of our applied research. We're doing applied research in a whole bunch of areas. I'll talk about some of them today. We also partner with the world's top AI laboratories, whether University of Toronto or Stanford or Berkeley or Oxford or Harvard or MIT or Tsinghua University or the University of Tokyo. We have some 20 some odd universities that we're working with around the world where the greatest, the brightest minds in artificial intelligence are supported and working directly with us so that we can advance the future of computing together. We also
พูดถึงว่า
have
ได้
dedicated
ร่วมมือกับ
teams
วิทยาลัย
working with each
มหา
of
วิทยาลัย
the
ต่างๆ นะครับ
I
ทั่ว
already
โลก
mentioned the number of healthcare companies that are here. We work with enterprise, we work with internet service providers, so that we can make this computing platform available to all. One of the most important programs that we have in the company is called Inception, and many of you in the audience are part of this program. There are 1,300 startups that we're working with today that are focused on deep learning. You need early access to technology. You need access to resources. You need access maybe to expertise. You need access to market exposure. Sometimes you need access to funding. We have access and we provide all of that as part of Inception. 1,300 companies came out of nowhere. This program is literally 18 months old. There are all kinds of great companies here. Deep genomics and
พูดถึงการ
healthcare.
ใช้ Deep Learning เนี่ยมีใช้ในหลาย ๆ วิชาชีพนะครับ อย่างเช่นพวกทางการแพทย์ ทางธุรกิจเกี่ยวกับเชิงธุรกิจนะครับด้านความปลอดภัยอะไรต่าง ๆ เยอะแยะมากมายนะ
Taxi that they're building. There's Drive AI, who's building a software stack on top of Drive PX. Amazing companies out there. Blue River is using autonomous machines to make it easier for farmers to fertilize their fields. One particular company that I want to mention that's really, really cool, and it's a company that is, in fact, now working on deep learning. It's just the technology that they create is so vital to almost everybody who's working in big data. And it's a company called MapD. Todd Mostek's company was the world's first to create basically a database engine on top of GPUs. And he's been working on this for quite a few years. And he just recently open sourced MapD. You should all take this. It's just completely amazing to be able to access databases so large.
รอสักครู่นะ
มันจะเป็นเรื่องที่น่าสัศจรรย์มากนะครับ ถ้าเขาจะเปิดให้ใช้ GPU ตัวเนี้ยในโอเคในวงการแพทย์หรือว่าจะเป็นจบแล้วเหรอ
ยังมั้ง
ยัง
Deep learning and enterprise. SAP is one of the world's largest enterprise software companies. And recently they reached out to us and wanted to partner with us on deep learning and our engineering teams have been working together on a new product that is just super cool. It's called Brand Impact. And the way that this works is this. There are videos being shown by advertisers, and they spend some $60 billion a year advertising their brands and advertising products, but they really have no idea how effective they are. So let me run this video for you and you get a sense for it.
SAP Brand Impact is a fully automated and scalable video analytics service for brands, media agencies, and media production companies. Detected brand assets are framed in the video and correspond to the lines in the panel below. It allows interactive review of original video footage overlaid with detections. In the summary view, you get reports on brand exposure duration and size on the screen. In the detailed view, you get indication of each brand screen coverage and frequency of exposure graph. SAP Brand Impact solution, accelerated by Nvidia, enables customers to measure the impact of brand exposure on their business performance.
อธิบายนิดนึง
It makes so much sense for SAP to be working on deep learning.
ตะกี้เขาเอาพวกวิดีโอเกี่ยวกับการแข่งขันรถเนี่ย
of the world
ก็คือใช้ deep learning เนี่ยมาจับภาพว่าโลโก้สปอนเซอร์เนี่ยมันขึ้นกี่เฟรม จะมีคนเห็นเท่าไหร่ แล้วก็มาประมวลผล
have their databases all within the SAP ERP system. So they're sitting on a pile of data. Companies who are using SAP are sitting on a pile of data. If we could figure out a way to use AI so that we could harvest, so that we could find insight in that dark matter, it would be incredibly valuable. It's one of the reasons why we partnered up with SAP and the results. This is the first results of it, and you're going to see a lot more to come. Well, there's so many different startups that are emerging all over the world, but the part of it that's really, so you're seeing startups that are emerging, number of applications is exploding, the number of industries that are being touched by this, and simultaneously, the complexity of the models are exploding. This is Microsoft's ResNet, the groundbreaking work that achieves superhuman levels, has 7 sextillion operations, 7 exaflops. 7 exaflops. Just to give you a sense, if you took all of the world's fastest supercomputers, all top 500 of them, you put them all together, and if you could figure out a way to cause them to operate for 1 second together, that is 1 exaflops. So what this network, this model that Microsoft created, called the ResNet, really, really super deep, the deepest network at the time, it would take 7 seconds for every single supercomputer on the planet, all the ones in the United States, all the ones in China, all the ones in Europe, you gang them all together, it would take 7 seconds to process this network. Okay, that's how much operation is inside. Very few of us think about the word sextillion every day. These are big numbers. These are a whole bunch of numbers, and that is what a program looks like in the future. Well, the program is getting larger and larger. Baidu has a network, a model that's 20 exaflops large with 300 million numbers inside it. And that's called Deep Speech 2. And Google's recent neural
พูดถึงการใช้ deep learning เนี่ยพอถึงเวลาผ่านไปหลายๆปีนะครับข้อมูลที่เอามาประมวลผลนี่ก็จะเริ่มมากขึ้นเรื่อยๆนะครับกราฟอันสุดท้ายนี่พูดถึง Google
to run through this network one time. This is the ultimate high-performance computing problem. And that's one of the reasons why we have to continue to push the living daylights out of computing. Ladies and gentlemen, I would like to introduce you now to the next chapter of computing, the next level of computing. I would like to introduce you to something that has taken several thousand engineers, several years to create. It is a masterpiece on many levels. It is the most complex project that has ever been undertaken. Arguably the most expensive computer project the world's ever done. Ladies and gentlemen, the Tesla Volta V100.
มาแล้วนะฮะ Tesla V100 นะครับเป็น GPU
This is
Volta
made out of TSMC's 12 nanometer FinFET, and I'm just getting a little exercise up here. 12 nanometer FinFET. The part that is really shocking is this is
ผลิตด้วยเทคโนโลยี 12 นาโนเมตรนะครับ
reticle limits basically means that it is at the limits of photolithography.
ถึงไฮไลท์ที่หลายๆคนอยากดู
Meaning, you can't make a chip any bigger than this because the transistors would fall on the ground.
กล้องขอชัดๆหน่อยครับ
Every single transistor that
ได้ใหญ่
is
มากครับ
possible to make by today's physics was crammed into this processor. 21 billion processors, almost 100 billion vias, little connectors, 100 billion vias. To make one chip work per 12-inch wafer, I would characterize it as unlikely. And so the fact that this is manufacturable is great. It's just an incredible feat. 800 millimeters squared. If you guys have an Apple Watch on your wrist, the die size is approximately like that.
บอกว่าขนาดไดไซส์อยู่ที่ประมาณ800ตารางมิลลิเมตรเงียบไปเลยฮะโอเค
results in
น่าจะเป็นปัญหาที่เด็ด
120 teraflops
จริงเน็ตผมก็ยังวิ่งไม่
of
เต็มเลย
tensor
นะ
operations. 120 teraflops. Unbelievable.
120 เทเลฟลอปนะครับประมวลผลได้
โอ้โห
แต่ต้องเข้าใจไว้อย่างหนึ่งนะครับ
This-
เทสลาเขาเอาไว้ประมวลผลอย่างเดียวนะครับ ไม่ได้เอา
Well,
มาเล่น
the
เกม
R&D
นะฮะ
budget is approximately $3 billion, and this is the first one. So, if anyone would like to buy this, it's $3 billion.
เขาเกเขา
I'll
เก
just
ครับ
stick that in my pocket.
อินสติ้งอ่ะ
The memory system in our architecture is quite unique. If you take a look at the way that most processors are organized, the register files are very small, the caches are very big, and the DRAM is quite large. In our case, the register file is huge, 20 megabytes of RF register file, so that the memory is very, very close to the processors, and that's one of the reasons why the throughput is so high. 16 megabytes of cache, and we're utilizing the state-of-the-art, the fastest memories that the world can make today. It's made by Samsung. Our partnership with them is terrific. The two engineering teams have been working so closely together,
แรม
pushing the
น่าจะเป็น
limits,
HBM2 จาก
pushing the
Samsung
limits
นะ
of
ครับ
how fast we can drive memories. And we've been able to achieve 900 gigabytes per second. It is just so fast. And then lastly, the second generation NVLink gives us 300 gigabytes per second, basically approximately 10 times the fastest PCI Express in the world today. Ladies and gentlemen, the Tesla V100.
ใช้ memory bandwidth 900 gigabyte per sec นะฮะค่อนข้าง
The
ความ
Tesla
เร็วสูง
V100 Volta has a new instruction inside. It's called the
เขา
Tensor
เก
Core.
ครับ
It's a
ตั
new
วของ
CUDA
AMD
tensor
ครับ
operation instruction that is both an instruction as well as data format. It's a
อะไรที่ AMD
4x4
ประกาศเอาไว้
matrix
เขาโอเค
processing
ครับ
array.
ขึ้นมา
And
อีก
it
อย่าง
basically does
memory
one of the
bandwidth
most important primitives of deep learning.
คือ
A
เท่า
times
ตัวเลย
B plus C on a matrix. A times B plus C on a matrix. And so the input is A matrix 4x4, 16-bit floating point, times B, 16-bit floating point, plus C. And we're trying to do that as fast as possible. So this is the way Pascal did it. And it did it incredibly fast at the time. And the reason why it's incredibly
อันนี้พูด
fast,
ถึง
every
Pascal
single
นะ
row is multiplied by every single, row is multiplied by every single
เทส
column.
ลาไม่
And then
ทัน
when you're
ขึ้นให้ต่อให้ดู
ครับ
สักหน่อยหนึ่งแล้วก็หายไปอีกแล้วรอสักครู่นะครับ
5,120 CUDA core นะฮะ
เป็นเรื่องปกติฮะเกครับทั้งที่ยังไม่ได้ผลิตคุณสราวุธ ต่อไปนี้
คือจริงๆเขาผลิตนะครับ แต่มันได้น้อย
We
ค
felt
รับ
that that just
เขาดู
wasn't
ได
fast
ไซส์
enough.
ใหญ่มาก
What we should do is to do it in parallel and in parallel. And so this is what the Volta
ดู
Tensor
ของปาก
Core
ของ
does.
คอ
It
นะ
literally
ของออกนะครับ
does the 4x4
อย่าเพิ่งเอาออก
multiply plus C
ดูกันก็ได้
at the same time. And it dumps it into result, 20 times increased throughput.
ทรานซิสเตอร์ 21 21,000 ล้านตัว ใช้ TSMC 12 นาโนเมตร
Really
FinFET
crazy
นะครับ
stuff. The net result
size
is although
815
Pascal, the
ตารางมิลลิเมตร
P100, is the most advanced processor the world's ever built. 1 year later, Volta is 1.5 times the floating point performance general purpose computing, 12 times the tensor operations compared to Pascal for deep learning training, and 6 times for inferencing. I'm going to come back to inferencing a little bit.
พวก deep learning เป็นหลัก
The work that they do, deep learning scientists that are so heavy, and building a supercomputer or a high-performance computing cluster takes a great deal of time. Integrating all the software into it to make it performant takes a great deal of time. And finding space for it takes a great deal of time. For many of them, they either aren't quite ready for the cloud, or would like to have the ability to burst into the cloud. And so we created for developers the
เขากำลัง
DGX1
พูดถึง Cloud Server ถูกไหม
clients dedicated to
ที่จะ
AI.
ใช้
With
Tesla 100
Volta, it has almost.
ไม่เป็น
I wish I just had 40 teraflops more, because it would have been wonderful to say. 960 tensor teraflops with 8 GPUs inside. It can now take what used to take 8 days on tight necks to train now literally takes 8 hours. What took a week now takes a shift, and it replaces 400 servers. I don't know if you know what 400 servers look like. It's basically a full aisle of servers. Today, DGX-1V. Yeah, is that beautiful? The DGX-1V with 8 Tesla Voltas. And call your operator
มาเป็นเครื่องเลยฮะ
You can order one today for
เครื่องละ
โอ้โห
$49,000. Come to
ล้าน
nvidia.com.
ครับ พวกเนี้ยการ์ดจออย่างเดียวหลัก
Have
แส
your
น
credit card ready. And we'll deliver it in Q3. Now,
149,000 ครับ
only for you in the room. Everybody who places orders now, I'll give you, because Volta is not quite ready to ship now, it'll ship very soon. It'll ship Q3 and DGXs and Q4 from OEMs all over
ดู
the
ทัน
world.
กันไหม
ไม่ทันนะราคาตะกี้เซฟทันไหมอันนี้
Starting today,
อ่า
you'll get a
ผม
free
มีอีกที่
upgrade
หนึ่งที่อยาก
to
ให้เห็น
Volta when it arrives in Q3.
ขึ้นให้ดูแล้วกัน
มา
นะ
มาควอเตอร์3
DGX-1V
จริงครับแต่ว่า
$149,000 replaces 400 servers or approximately a
เป็นต
couple
ลาด
of
เซิร์ฟเวอร์
million
ล้วน
dollars worth of equipment, and it comes out of the box, plug it in, and it
ๆ โอ้
goes
โห
away.
149,000 เหรียญ
Well,
อืม
we've
ขาย
been
บ้านไป
asked so
ซื้อ
many
นะครับ
times. Would it be nice? I don't have a data center,
อ่ะผมอยาก
and I don't have cooling. I'm a startup, and I've got 10 engineers. And what we need right now is to get working on deep learning. Could you please make us a small version of DGX? And so we thought, well, that's an interesting idea. So we prototyped up a few inside the company. And of course, putting that much computing power next to an engineer, you really, really have to keep it quiet. So we liquid cooled it. And it's whisper quiet. You can't hear it at all. And so we created it, and we can't make enough of it. Every single deep learning engineer in our company either has a DGX station or a DGX-1 or both. Every single one of the engineers. And so this is just an amazing success inside the company. And so I decided that we would make it and make it available to deep learning engineers all over the world. Ladies and gentlemen, the personal DGX, called the DGX station. And for those deep learning engineers that just started the company and would like to get going quickly, this is one way they
เป็
could
น
do it. And when they're ready,
workstation
post it up
ล้วน
into
ๆเล
the
ยอะ
cloud for a simple $69,000. You have your own personal
69,000 ฮะ
AI supercomputer. You can order it now, and we will deliver it.
69,000 ดอลลาร์ คิดเป็นเงินไทยกี่ล้า
Place
น
your order now.
น่าจะประมาณเกือบ3 ล้านบาทอะ
So that's one configuration of how Tesla gets used in a DGX station in DGX-1
ประมาณ
for a
2.5
personal AI supercomputer. The other way that we use it, of course, is putting it into the cloud. And one of the ways that we use it is putting it into a public cloud. When you put a service into a public cloud, GPUs are used in a whole lot of different ways. They might be used to train certain types of networks, and different types of networks like different type of computer configurations. They might use it to run molecular dynamics. They might use it to run, as Matt was saying earlier, a segmentation or maybe even a simulation or computer graphics in the cloud. And so we need this computer to be very adaptable. One of the things that we did was we partnered with Microsoft to create the industry's first industry standard hyperscale cloud graphics accelerator. Notice there's a computer, there's a 1U computer underneath the server. And there are these 4 cables that come out from the base computer into the HGX-1. And these cables are basically PCI Express, and allows us to configure this server in 2 CPU and 8 GPUs, 2 CPUs and 4 GPUs, 1 CPU and 2 GPUs, and so that they could provision all kinds of different size services to the market. And of course, we still have the ability to virtualize the GPUs so that many instances can run on 1
วัน
GPU.
นี้น่าจะเป็นโปรเจกต์
This
ใหญ่เลย
particular box is intended for the public cloud so that the versatility of service could expand the reach of the customer base. Whether you're using it for deep learning, or using it for graphics, or using it for CUDA HPC computation, HGX is really ideal. I'd love to have Jason Zander, who is the Vice President of Azure, come and join me. We've been partnered together for such a long time working on this. It's great to have you. Jason, welcome.
Thank you, Jensen. Appreciate it. Happy to be here.
You know, our companies work on, first of all, I'm really, really grateful that you're here. As you guys know, right now, simultaneously, Satya and Harry Shum, the CTO and CEO and the CTO of Microsoft, are up in Redmond doing almost exactly the same thing we are.
Our Build conference is today.
It's called Build. And so I'm really grateful that you took the time to come down here and spend it with us. We've been working with Microsoft for, gosh, 25 years. And we have all kinds of developments going on. Recently, we've been working on, of course, advancing deep learning for internal research. And very, very amazing. Well, first of all, Harry Shum, XD Huang are some of the world's
เดี๋ยวเราค่อยสรุปกันตอนท้าย
AI
นะครับ
researchers in speech.
คุณสราวุธถามว่าใครจะซื้อเหรอราคานี้พัฒนา
พวกโรงพยาบาลเนี่ยครับ พวกโรงพยาบาล
มัน
หรือ
ใช่
พวกกระทรวงต่างๆ ที่เขาใช้ในการวิจัยฮะมันเป็นโปรเจกต์ใหญ่ครับ บ้านอย่างเรานี่ไม่มีปัญญาซื้อครับเพราะมันแพงเท่าบ้าน
And of
แพ
course,
งหลังนึ
of
งเลยนะ
course, you guys had a great groundbreaking work with ResNet, developing a very, very deep, very sparse.
มันไม่ได้ขายระดับ home user นะฮะ
Superhuman levels.
เขาพูดถึง cloud server นะครับ
Microsoft
ธุรกิจ
uses a
ฮะ
framework.
แต่ไม่แน่นะ
ใช่
ถ้าทีวีสตีเทค
They call it CNTK,
รุ่งเรืองนะครับ
which has now
ฝัน
become-
ฝันครับ
ซื้อมาทำเซิร์ฟเวอร์ไหม
And
ฝันครับ
tell me about the
ไอตัว
work that you guys
สูง
are
สุดก็
doing and how you
69,000
guys
ละ
can expose
cloud
that to
server
the
เนี่ย
rest of the world so that everybody else can
มันไม่ใช่
Yeah,
แหลก
thank you.
เซิร์ฟเวอร์เรามาต่อกัน
AI
เอง
is
นะ
a
ฮะ
clear part of what we're trying to do. We want to
top suit
infuse
ก็แค่
AI
5 ล้าน
across
เอง
our entire platform. So we start off with the platform, our
ขายบ้านมา
partnerships
ซื้
that
อ
we
แลน
have,
ไหม
cognitive services and frameworks like Cognitive Toolkit are now
วันนี้
the
มา
cognitive
2 ตัว
toolkit
ตัว
used to be
2 ล้าน 5
CNTK,
กับ 5
but
ล้าน
also
เอง
into our applications because we want users to
เอ
be
ง
able
นะ
to
ฮะ
take advantage of that as
ซื้อ
well. So that's
BMW
available
ได้
for
เลย
them.
คัน
It's we've been doing AI for a good 20 years now. If
จัด
you think
BMX
back
ไป
to
ก่อน
things
เลย
like search relevancy, all the way out to things like Kinect sensors on the Xbox,
ถ้า
and
ดู
most
แล้วตัว
recently
ที่เป็น
HoloLens,
G-Force น่าจะมา
and
มี
those
หน้า
environments.
แบบ
You mentioned the real-time speech translation, the
หรือ
Skype
ถ้ามา
real-time
เสียงมันตี
translator.
กันมาก
That's one of the most sophisticated
เดี๋ยวเราลอง
language
เขาจบก่อน
deep
ดีกว่า
neural nets that are out there. It can take us hundreds of GPUs. We can spend an entire day running this thing through. But it's really cool because I can talk to someone in English and they can hear in Chinese and go back and forth. And you say lots of languages. Can't do that without the power
The
of
Star
both the
Trek
cloud
Universal
and
Translator is
GPU.
going to happen.
It's awesome. It's finally
Yeah.
here. Really excited.
And so I could just imagine. So that's right. So you guys are working on a HoloLens, and the HoloLens is, as you and I know, and it is real-time 3D reconstruction. It recognizes the 3D environment, and it augments computer graphics and register it perfectly inside reality, augments reality. And now, if you supplement that with the Cortana natural language translator, you're able to walk up to anybody from
พูด
another
ถึง
country,
Cortana
and you
เนี่ย
can talk in your language, they can
Yes.
talk in their language.
ระบบ AI
and the
เขา
two of
เจ๋ง
you
นะ
can have
ทาย
a
ผล
perfect
บอล
conversation.
ถูกด้วยนะ
It's really cool. I mean, the idea that I can trap photons and do
บอลโลก
something
ครั้ง
that
ที่
before
ผ่าน
just
มา
one
ผิด
eyeball.
คู่เดียวเองมั้ง
So that's another exactly great place where we're able to leverage the work that we've done together because doing the API and algorithm validation on the back end for the HoloLens, also another thing we can use inside of the fleet. Combine that with real-time translation. Like you said, I can have this really cool interaction model that's there, and you can't do it without the deep partnership that we've had, already so far.
Nobody would have guessed that Microsoft would be one of the fastest growing cloud providers on the planet. And in the last several years, your Azure business has just been on fire. And you have had the support of Natia and everybody is behind your business, pushing Microsoft Azure into the world. And so tell me about some of the efforts there and talk to
the Volta work that's coming out. We want to make sure that that goes out there as well. Look, my job is to make sure that both my internal folks inside of Microsoft developers, they use the Azure cloud in order to be able to do their training. Like the examples we just mentioned. And look, every time you come up with a new system that comes through, they want it tomorrow. And so our ability to come in and make sure that it's part of the training regime that we've got, it makes things go faster, like your benchmark showed. But then we also want to make sure that it's available to all of you. And we've done additional things. For example, our cognitive services we've had out. We've actually had it out for about 3 years now. We've been doing AI and speech and text and these APIs as part of the services on top of the Azure cloud, and we're bringing even more of those coming forward. In fact, we just announced the Azure Batch AI training service that's out there, which kind of, our history is a lot of developer stuff, right? We want to democratize that, and so we want, data scientists and basically developers that are working on models, let them concentrate on the models and the unique IP and value they add, and less on the plumbing. So you're going to see more and more of that come in through the system. We think it'll help accelerate some of the scenarios that you're showing.
Yeah.
It's really super exciting time.
Well, Satya is going to be super excited about the work that we're doing together. You guys announced yesterday the largest installation of GPU cloud that Azure's ever announced, and so I'm super excited about that. Thanks for your support, and thanks for support with Volta.
Thank you so much.
All right,
Appreciate
thanks,
it.
Jason.
Thanks.
Jason Zander, Corporate Vice President of Microsoft. Let me talk about inferencing. So now we've created this network, and it's taken hours and hours of deep learning training on DGX-1 or in the Amazon cloud or in the Azure cloud with all these GPUs. Now that you have this network is now ready to be deployed. And that network is still very computationally intensive, and we need to figure out a way to make that network run as fast as possible. There are two things that we are doing with Volta that is really, really special. The first, of course, is the Tensor Core that I mentioned earlier. It increases the throughput of training by a factor of 12, but it increases the throughput of inferencing by a factor of 6, and I'm going to show you the benefit of that. But the second thing is this. Whereas the frameworks are used for training the network, when you're done with it, it creates a graph, and that graph needs to be optimized and compiled for the processor that you're using. We call that Tensor RT. Tensor is basically a mathematical object. It's like a vector. It's a generalized vector containing a lot of multidimensional objects within it, and this tensor needs to run in real time, and it comes into our software in the form of graphs. And so the first thing that we have to do is we have to interpret from each one of the frameworks, parse and ingest from each one of the frameworks. The second thing we have to do is compile it, and the third, optimize it for each one of the targets. And each one of our GPUs has slightly different architectures. They have slightly different numerics precision, and we have to take advantage of each one of our GPUs. We call it Tensor RT, Tensor Runtime, Tensor RT, graph optimization for vertical and horizontal layer fusion. So if you take a look at this, this is basically a neural network. There's the convolution layer, the bias layer, the rectified linear unit layer, and basically the activation layer. And this is one particular network, that a typical network. This, I believe, is AlexNet. What we do with it, the first thing that we do is combine the mathematics that otherwise would have to be done in sequence into one big blob. And so we turned a ReLU, a bias, and a 1-by-1 convolution into a 1-by-1 convolution bias ReLU. And so that mathematical block is replaced. So by analyzing the graph, we could figure out which one of the mathematical operations we could fuse together and replace with something much more efficient. The second thing we could do is we could recognize when different mathematical blocks share the same inputs. They have different outputs, but they share the same inputs. And that, again, is achieved through graph analytics. So we can walk through the graph, we can analyze the graph, and recognize these different opportunities, and simply remove them, okay, in this particular case, and share them. And then the third thing, of course, is compile it down to the precision of the target GPU. Now, this is the inferencing performance. Let me show you. Broadwell, this is the fastest CPU of today. Skylake is the next generation CPU. We haven't had a chance to benchmark it yet, and so we're giving it the full credit of what's possible. K80 is the GPU that we announced 5 years ago. Okay, and the y-axis is images per second, how quickly it can do inferences in 1 second.
จะเทียบว่า P100 เนี่ยแรงกว่า Skylake 2 เท่า
There are two important numbers. Not only is the throughput important, but the latency, how long it took you to do it. Not how many you can do, but how long it took you to do it. The latency is equally important, and the reason for that is because if you were talking to a neural net, if you were talking to Cortana, and you asked Cortana the question, you would like it to respond very quickly in just a few milliseconds, And so the number of people who could speak to Cortana at the same time in the cloud is important, because that has something to do with the capacity of the data center and the cost of the data center. The second thing is the latency of that performance is equally important, if not more important, and the reason for that is because that has something to do with the quality of service. Okay? And so the purple line is latency, the green line is throughput. So P100 has the benefit of 600 images per second, and Skylake is about 300, the next generation Skylake, and both of them could do it in about 10 milliseconds. This is what Volta looks like.
คุณออสส่งลิงก์มาให้นะครับในแช
That
ท
is what we call a little
บอก
bit
ว่าหุ้น
fast.
ขึ้นเลย
And so
อันนี้
Volta is
คือ
really
จะบอกว่า
groundbreaking.
แรงกว่า
Not only is
สกายเลก
Volta
ประมาณ
incredibly good at training,
20 เท่า
it is
ใช่ไหม
also incredibly good at inferencing for the
Latency.
very
ประมาณ
first
นั้น
time. We've not focused on inferencing in the past, and the reason for that is because the number of networks that are being created was still rather limited. But now, internet service providers and cloud service providers and startup companies and enterprises all over the world are starting to move deep learning into production. They need an inferencing pipeline. And so Volta, TensorRT, ideal for inferencing. The way that we deploy it into a server is also unique. And the reason for that is because these scale-out servers, gosh,
นี่ไง
Sandy,
บอกว่าแรงกว่าสกายเลกประมาณ 15-25 เท่านะ
why do I keep going over there? Sandy, stage manager, she's fantastic. Ladies and gentlemen, this is Tesla
อันแน่
for
Tesla ตัวแรก
hyperscale scale-out. Look how small it is. Look at this thing.
ใช้ HBM2 มันก็เลยเล็กลงเยอะ
It's
เลย
like a CD case,
ราคาเท่าไหร่ฮะ
but more beautiful.
เอื้อมถึงยากครับ ขั้นต่ำก็น่าจะ 4,000 เหรียญขึ้น
ยังไม่บอกเลย
It might actually be real gold. Okay, so Tesla V100. And this is what we call the PCI Express FHHL, the sexiest name ever. Full height, half length. Who does that? I couldn't rename it. It was too late. The industry took it and ran with it. Full height, half length. Try to say that without chapstick. Okay, so this is, and not only that, it runs at 150 watts. 150 watts. 150 watts. And it fits into these
150 วัตต์
commodity
กิน
inferencing
ไฟ
servers. And here's the,
โอ้โห
thank you, Sam.
ไฟต่ำมากอะ
This is the case I want to make. This is the reason why people are talking about accelerators for data centers. I like to make the case for accelerators.
แต่ว่า
Here's how it works.
มันไม่ได้เอาไว้
And so this is what
game นะครับ
500 nodes look like.
ไม่
Remember I said 400
เข้าใจ
nodes? This is what 500
แต่ว่า
nodes
ถ้า
looks
เทียบ
like.
ประสิทธิภาพ
500 nodes is
ในการ
basically this
คำนวณ
entire
มัน
row
อะ
of
กับ
servers.
วัตต์ที่มันเกิดขึ้นเนี่ย
Okay?
มัน
This
ถือ
entire
ว่า
row of
ต่ำมาก
servers,
เลยนะ
500 nodes.
ใช่ครับ
Well, basically, this 500 nodes can support 300,000 inferences per second. 300,000 7 millisecond inferences per second, which means if 300,000 people were connected into this data center and did a query or okay something or look for something,
สัก
and
ตัวไหม
those
ครับ
inference networks were
ขายบ้านไป
activated,
ซื้อเลยครับแอด
we
มิน
could support 300,000 people in this rack. 300,000 inferences basically translates to about 1,000 CPUs, because as you saw earlier, the state-of-the-art CPU, the one that hasn't been announced yet, is 300 inferences per second. And so 1,000 CPUs basically translates into 2 nodes, because each one of those little
เขา
nodes, long
จะเปรียบ
nodes,
เทียบ
has
ไม่
2
ใช่ใช่ไหม
CPUs
ฮะ
inside.
CPU
If we added
server อะ
all of that
ที่
together,
ต่อกัน500 ตัว
$3,000
เทียบ
per
เท่า
node.
Tesla V100
And remember, you have to buy the node.
ตัว
there's
ตัว
the
เดียว
interconnect,
คูณ
okay,
10
and there's all of
คูณ
the power that
15 ฮะ
goes along
คูณ
with it.
15 ตัว
Power
ต่อ
and
กัน
cooling represents about 40% of a data center. But let's ignore all of that for a second. And so 500
ไป
nodes
ไหน
translates to basically $1.5 million.
ไม่ใช่ 15 ตัวครับ ก็ใช้คำว่า reduce 15x ก็คือมันใช้พลังงานลดลงอ่ะ 15 เท่าเลย
อ๋อเหรอฮะ
500 watts each, so 250,000 watts, 250 kilowatts. Well, if Tesla, if we used a relatively conservative number of about 15x reduction, that basically translates to 33 nodes of this. That translates to 33 nodes. That's the savings. instead of 500
ก็
nodes
คือใช้
that
ใช้
occupies
การ์ด
an
จอแค่
entire row, you
32
can
ตัว
replace it with 33
อื
nodes.
แทน
ม
CPU server จำนวน
You could
ประมาณ
increase the throughput of
500 ตัว
your data
ครับ
center by
โอ
50
เค
times and not have to build
อ๋อ
more data
เห็น
centers
ละเห็นละ
as AI workloads
GPU
flood
33 ตัว
into
ตัวเทสลา
hyperscale data centers.
ครับ
This is one of the most
GPU
important reasons
33
why
ตัว
people ask us about
ใช้แทน CPU
FPGAs
server
and
จำนวน
accelerators and
ตัว
so on
เข้า
and
ใจ
so
ละ
forth. And we decided
15x
why not
reduce
make
15x หมายความ
Volta
ว่าเขามี
the
ประสิทธิ
best
ภาพประมาณ 15
inferencing
เท่าใช่ไหม
machine that
ไม่ใช่ครับ
can
เขา
possibly
ใช้
make.
พลังเหมือนกับ
And
ว่า
as a
ใช้
result,
พลังงาน
the
น้อย
results
ล
are
ง 15
incredible
เท่า
amounts
เมื่อ
of
เทียบกับ
savings. Okay?
CPU
So
ที่ประมวลผล
Tesla
ที่เท่ากัน
Volta for
โอ
inferencing.
เคครับได้ละ
ก็คือแทนที่จะต้องใช้
Let me show you
CPU
one more thing
server
that's really super
500
important.
ตัว อันนี้ก็ใช้แค่การ์ดจอ 33 ตัวเท่านั้นเอง คิด
We've
ไฟ
been
น้อยก
working
ว่านะ
on all of these stacks, and the stacks are so complicated. You got
ใช่
a whole bunch of GPUs, whole bunch of drivers, whole bunch of systems, whole bunch of middleware, all these different numerics, all these different frameworks, and there's so many frameworks, there's so many GPUs, there's so many versions of software. The ability for the industry to maintain all of this complicated stack of software, arguably the most complex stack of software the world's ever seen, is really, really, really difficult. And in fact, when you read the forums, it is such a pain. And for many deep learning engineers, it takes anywhere from a solid day to a couple of weeks to sometimes never achieving building a computer that can do deep learning. And so what we decided to do was take this incredibly complicated stack and containerized it. We containerized it, and we dedicated ourselves to containerize every single framework and every single version of software that we know. And then once we containerize it, we're going to create a cloud registry for it. Okay? We're going to create a cloud registry for it. We're going to take all these containers, we're going to create a cloud registry for it, and here's how it works. So whenever you're ready and you have a Titan X, and you're one of the several 100,000 deep learning engineers in the world that has Titan X's, and you bought a Titan X, you don't want to build your own deep learning machine, you simply go to a website, type in your email address, register for this, you download the container of your choice. You download the container of your choice. That entire stack of software is fully optimized. It's fully integrated. It's containerized. It's virtualized. We download that into your machine. You start doing deep learning basically in a few minutes. There's no configuration, there's no building, there's no worrying about different versions. It's configured basically in just a few minutes. It uses a container called the MV Docker, and we create a registry for it. We support every single framework. Then the next thing is, once you start using, you used to use the platform, you start to realize that, gosh, I sure would love to have a lot more performance. And nothing would give me more joy than to tap into the 10,000 GPUs that are in the cloud. With just a click, you create an instance up there, we download the container up there, and we burst your workload into the cloud. Okay? So this is really the first hybrid deep learning cloud computing platform. And what we provide is just a registry. We provide the registry, the cloud computing platforms provide all of the cloud computing infrastructure, and we maintain the software, optimize the software for as long as we shall live. Let's take a look at it. Phil.
Yeah, so
เป็นซอฟต์แวร์
NVIDIA
ไม่สำ
GPU
เร็จเลยนะฮะ
Cloud provides multiple interfaces for
NVIDIA
developers
GPU
and
Cloud
users to run deep learning.
เขาบอกว่า
I'm going to focus
เข้าไปโหล
today
ด
on
แล้วก็
the
ใช้
web
ได้เลยนะครับ
application running in a browser.
เสร็จใน
So
3 นาที
you log in. And this is where you create your deep learning job. And there's just 3 steps. First, we select where we're going to run our deep learning workload. We call this the accelerated computing environment. You can pick from cloud or your own DGX1 cluster or a DGX station or a Titan PC. Today we're going to focus on cloud. And you can see the options you have here include the Microsoft Azure, Amazon AWS, and the Nvidia Saturn V. This is the DGX supercomputer we built for internal development. I'm going to select an 8 GPU node because I'm going to run a fairly heavy ResNet training session. In the second step, you attach a data set or multiple data sets to your job. Here, and you get a choice between the existing data sets that you've already uploaded, or you can create and upload a new data set. I'm going to go with the ImageNet data set, and this particular data set has both training and validation samples in it, so I only need one data set for this run. Next, we select the framework in a container, as Jensen was just describing. All of the different frameworks are provided, fully optimized, and optimized for scale out to multi-GPU, so ideal for our 8-GPU run here. I'm going to take PyTorch, and I'm going to take the latest release. You notice the numbered releases. We optimize, update each of these frameworks every month. So at this point, my job spec is complete. I'm ready to go. But I want to notice that we echo out the command line that's equivalent to this web application run so that a developer can copy and paste this into a script and run it from one of our other interfaces, such as our command line interface.
เขียนซอฟต์แวร์มาได้ดีมากเลยฮะสะดวกกว่าการใช้งานจริง
This is the control center
เลือกสเปค ออฟสคริปต์ไปวางใช้งานได้เลย
running and queued and your recent history. And the list of jobs covers all of the accelerated computing environments that you've been running in. And you see the job at the top is the one we just created, the ImageNet 256. It's already running. And you can click on any job to look at telemetry. There's a job here on 4 GPUs I started a little while ago. It's also ResNet on PyTorch. And you can see we're keeping these GPUs running flat out as we run this training session.
That's great. Thank you. Good job, Phil. And that's it. That's the GPU. That's the GPU cloud, the NVIDIA GPU cloud. And it's a containerized system. It's a registry in the cloud, supports every single framework. And the thing that we will do is we will support these frameworks and every single one of the versions and every single one of the permutations of them on every single one of our GPUs for as long as we shall live. And that's something we do for accelerated computing for each one of the markets that we serve. It's going to be available beta in July. The NVIDIA GPU cloud platform. Okay? For all of you who are anxious to burst into the cloud, this is the way to do it. All right, so let me summarize quickly on accelerated computing. If you take a look at some of the results that I've shown you, it is very, very clear that as Moore's Law comes to an end, that accelerated computing is really a wonderful path forward. And it's a wonderful path forward because of the architecture, because of the system software stack, and because of the domains that we've selected, and the fact that we work across each one of the applications middleware and the architecture in an iterative basis. And over time, you can see that the results continue to compound. On the left is Amber performance, molecular dynamics. On the right is GoogleNet, deep learning. In both of those examples, we continue to advance. I want to now talk about AI at the edge. I've got some delightful things I want to share with you. I'm going to go quickly. You guys know that we're really dedicated to the automotive industry. And the reason for that is we believe that everything that's going to move someday will be augmented by autonomy. Everything that's going to move someday is going to be augmented by autonomy. We're enjoying, as you know, the Amazon effect. As we every single day buy things, don't forget, we used to drive to the store to pick up things, but now we expect the things to come to us. The number of truck drivers, the number of transportation professionals can't keep up with the Amazon effect. And so we have to find a way to automate as much of that entire path as possible. Augment it, take pressure off of the drivers. The number of truck drivers, for example, in many countries is short by about 50%. And so we need to find a way to automate some of this so that we can keep up with the Amazon effect. Not to mention, society could be much, much more beautiful, and our environments could be much more beautiful if we didn't have so many parked cars. Very few of us would remember that for every car that we own, there's actually 3 parking spaces created for us, not even including the one we already own. And so there are 800 million parking spots in America. There's only 250 million cars. And it makes a lot of sense because we just never know when we need it. Okay, so I think autonomous vehicles, transportation will be augmented by autonomy in the near future. We've created a platform we call the Nvidia Drive. And basically, it's a roadmap. It's an architecture that spans level 2 to level 5, from augmented driving all the way up to completely driverless systems. We created a full stack. We dedicated ourselves to go solve the self-driving car problem and create the software stack, but open up the software stack. To create the software stack, understand the problem deeply, but to open it up. And keep it open so that hundreds of people can use it. We now have 200 developers around the world using Drive PX. They're startups, they're shuttle companies, they're car companies, they're trucking companies. We have wonderful partners in Bosch, the largest tier 1 in the world, ZF, the largest trucking tier 1 in the world, PACCAR trucking company, all the startup companies that I mentioned earlier today. It's all possible because the Drive platform is open. And it's open on so many different levels, you can intercept it at any level that you desire. Let me show you a couple of videos of what it can do, and then I got a big announcement I'd like to share with you. And so the first thing is this. The first thing I'm going to show you is mapping to driving. Basically how the car figures out where it is in the world and localize within it and detect everything that's around it and drive. The second thing that I want to show you is how we use AI not just for driving, but also to be essentially a virtual co-pilot. And third, this is a phrase that Gil Pratt at Toyota created that I really, really love, and it's called a guardian angel. Even when you're not driving, even when the car's not driving for you, even when the car's not driving for you, it should be watching out for you. And so the AI is on all the time, even if it's not in autonomous vehicle mode, it should be watching out for you. So let me show you a couple of videos. The first one is mapping to driving. And so in this particular case, the first thing that's happening is we're using the LiDAR. We have a LiDAR mapping car, and we're trying to detect everything
ถ้า
that's
ดู
around
ดี
us.
ๆจะเห็นว่า
The vertical
ตัว
poles. We're trying to create essentially
AI
an
นะครับ
HD map of
อันนี้ใช้กับ
structures
รถยนต์
in
ที่
the
ไม่มีคน
world
ขับ
that we
นะฮะ
ought to use to localize
ขับของมัน
ourselves
ไปเอง
later.
นะจะมองเห็นเส้นของเครื่องหมายจราจรต่างๆบนพื้นถนนแล้วก็สิ่งกีดขวางต่างๆที่อยู่บนท้องถนน
We create the middleware, and there's a great company called DeepMap who does this, and of course TomTom does this, Here does this. Mapping company, we're partnering with mapping companies all over the world, and now we put that into our car, and it's in autopilot mode. Notice it's detecting the cars around it, it's detecting the lanes, detecting all the signs, and now you have confidence that the BB-8 is driving safely in the road, okay? And the next one is Copilot. This is our own Janine.
I can now drive you to work based on mapping previous drives. Shall I engage autopilot?
Oh, sure.
Autopilot engaged. Driving to work.
Janine is
หมดขี้เกียจนะฮะ
in
Autopilot
our marketing department, and she's also one of our test drivers. She's very, very brave. And so,
แอดเนสสนใจหารถแบบนี้มาขับ
beautiful
บ้าง
and
ไหมฮะ
brave.
ขับไป
All
ทำ
right,
งาน
so she has the benefit of a co-pilot.
สนใจสาวในรถ
And
มากกว่า
basically
ครับ
what's happening is this. Of course, we're not going to have the whole world mapped. And we're going to map the world as fast as we can, and wherever it is mapped, the car should know, and it just lets her know that, hey, gosh, I could drive the car for you now. Would you like me to take over? And the next, let me show you Guardian Angel.
อันนี้เวลาขับรถแล้วพลาดนะครับ
There we go. Green light. Time to go.
Cross traffic danger.
Maybe not.
All clear.
Disaster averted. Okay? And so this is possible because the car sees everything.